Welcome to EDU World Space.
So we're told that we're shooting a water hose at an angle of 45 degrees above the horizontal. So then the sine of the angle is equal to the cosine of the angle. It's just going to be equal to root 2 over 2. And it says that it's shot into a large cylindrical storage tank of a diameter d and a height of 2d. So it wants us to figure out the range of launch speeds v naught that will enter the tank. Ignore air resistance and express our answers in terms of the distance d and gravity g when we're 6 meters away from the base of the tank. Okay, so that's what we have. The acceleration in the y direction is minus g. We're going to say that we're starting at the origin, so x naught equals y naught is equal to 0 here. So the water moves in a projectile motion. So for the minimum distance here, since we're asked to find a range, we're going to find a minimum and a maximum. So we're going to define this one as the minimum distance. So we'll just write min, maybe underscore that. For the minimum distance, x is equal to 6d, which is equal to root 2 over 2 times the velocity initially, v naught, because v naught times the cosine of theta is equal to the velocity in the x direction. So that's v naught times root 2 over 2, and then, of course, multiplied by the time. Therefore, the time is equal to 6d multiplied by root 2 divided by v naught. Okay, therefore, we can plug this value for t into our equation of motion for y, which says that y here is equal to 2 times distance d, which is equal to our equation of motion for y, which is the velocity in the y direction. So that's going to be root 2 over 2 times v naught multiplied by the time, t, minus 1/2 g. The minus sign comes from the fact that gravity is acting in the negative direction, multiplied by the time squared. So therefore we have 2d is equal to, plugging in the value for time, the v naughts are going to cancel, and then this is going to leave you with 6 times d. Let's rewrite that d here. Okay, minus 1/2 times gravity, and then plugging in the value for t, again, it's 6 times d times the square root of 2 divided by v naught, and then all of that is squared because that time value is squared. Therefore, we can solve for v naught, and that gives 3 times the square root of g times d. So there is the minimum velocity value in terms of gravity and the distance d. Now we can use the same method to find the maximum velocity value. So we just get a new page going here. We'll call this max. For the maximum distance, x is equal to 7 times d, because that's the backside of the pail, since the pail has a diameter of 2d, or the cylinder, excuse me. And this is going to be, so it's going to be 7d times, which is equal to the velocity in the x direction, which is root 2 over 2, multiplied by the time. Therefore, the time is equal to 7 times d times root 2 divided by the initial velocity, v naught. And then again, we have the same equation of motion for y, and y again is equal to 2 times d, which is equal to v naught y times the time, which is just going to be equal to 7d. Since previously it was 6 times d, this time it's 7 times d, since our distance changed, minus 1/2 g, and then the value for time is 7 times d times √2 divided by v naught, all squared. So again, using the same method, solving for v naught, we find in this case that v naught is equal to 3.13 square root of g times d. So as expected, it is slightly larger because previously it was 3. So our range is 3 to 3.13 g times d. So we can box that in as our maximum value, and we'll box this in as our minimum value of our range.